5, 4. All right, so we're in Windows world again, and we're talking drivers. And please introduce yourself.
Okay, I'm Donn Terry. I'm a developer, and my responsibility for the last several years has been PreFAST for drivers.
Mm-hmm.
And seeing that I'm talking to a driver's audience out there, I really hope they're using it.
Cool. So to begin, obviously, let's talk about what's PreFAST and what is this technology?
Okay, PreFAST is in the broad sense, a static analysis technology.
Mm-hmm.
The objective of it is to not quite but almost execute your program in all the ways that it can be executed, not just the ones that you can drive with a test case,
mm-hmm.
and try to find as many of the things that it can that goes wrong. Mm-hmm. We actually have a couple of different static analysis tools. Static Driver Verifier, which is a very, very powerful analysis tool, but it takes a long time to run and finds a relatively limited number of bugs over a limited set of drivers at the moment. Mm-hmm. And we're clearly working on making that better. PreFAST for drivers doesn't go as deep, but on the other hand, it's a lot faster, a lot lighter weight for you to use, mm-hmm. and is sufficiently lightweight that you can use it just every few minutes as part of your development process.
Okay.
So you as a developer can run PreFAST for drivers as soon as you have code that compiles. Mm-hmm. And even if it isn't complete code, it might find a few bugs, and if you're going to end up cutting and pasting a piece of code with a bug in it, mm-hmm. when you find it early, you won't cut and paste that bug into 15 different places.
Yes. So why make a different PreFAST from what I can use as an application developer using C++ code in my language?
The real reason for doing that is that PreFAST for drivers has a lot of driver domain specific knowledge. For a concrete example, it understands what an URL is. Standard PreFAST has no idea what an URL is, has no rules around URLs. Mm-hmm. But for PreFAST for drivers, it has a lot of rules around the proper use of URLs, and therefore will catch a lot of the errors that people consciously or unconsciously make in terms of using URLs. And there are a lot of other similar statements I can make about different technology areas where PreFAST for drivers knows things about drivers that an application program wouldn't care about, and therefore a PreFAST for an application program wouldn't care about.
Okay, so for the people in the audience who don't know what an URL is, because there's students out there and also non-driver developers that will be watching this, what's an URL?
Interrupt request level. It's basically just the mechanism by which things are kept slightly in order as asynchronous events come in. Mm-hmm. And to some extent, the example, the word URL could just be used as a magic word.
Interesting. Cool. So you've written this obviously in C or C++.
Yeah.
And did you leverage a technology already existing? So basically, you just built on top of PreFAST?
I built on top of the standard PreFAST, which is currently available for applications in Visual Studio, 8 or whatever the most recent Visual Studio.
2005. Yep.
Okay, 2005. It's available in the most recent version of that in the Enterprise Edition and one other of the high-end editions. Not by name, but just as the /analyze command line option.
Sure. Okay.
And if you're writing in application space, it's a good tool to use.
Yeah.
But if you're writing driver space, PFD is the better tool to use.
And that's a command line tool? PFD?
Yeah, PFD is a command line tool. You don't need any fancy GUIs or Visual Studio. It just runs in the normal Razzle build environment.
Very cool. So let's talk a little bit about the complexity of driver development and how this tool specifically helps with writing non-buggy code. So for example, in the kernel, when you're writing drivers, you make a mistake, you just blow the system, right? From an NT policy standpoint,
right.
The system it says, okay, we're done.
You get the wonderful thing called a blue screen.
Exactly. And so with this technology will help driver developers write less buggy code because it catches them at compile time or runtime?
It catches them between compile time and runtime.
Okay.
You compile and you found a set of clear syntax errors and gotten rid of those. When you run any PreFAST, but PFD specifically, you find an additional set of errors which are pointed out to you as if they were syntax errors. They said, you did this the wrong thing right here.
Okay.
Go look at this. This is wrong. And usually it's as quick to fix as a syntax error. And you don't then have to worry about that class of error showing up in your code. Like the compiler, PreFAST only works really at a per function level. So if you have an error where part of the problem's in one function and the part of the problem's in another function, PreFAST won't find it. That's what SDV is for.
SDV?
Static driver verifier.
Okay.
Which I mentioned
earlier.
But for a lot of the errors where they can be detected within a single function, you simply run it. It tells you did this wrong. You say, oh, okay, yeah, I'll fix that. And it's that quick. And a lot of those errors can be multi-day bugs when you're trying to find them the hard way, even with the dynamic driver verifier, because or the thing known as driver verifier, dynamic driver verifier, to be clear. Because driver verifier tells you what the damage was. PFD and SDV tell you what you did wrong, which gets you a lot closer to the fix.
Sure, absolutely. Now, how does it work in terms of many of the most egregious bugs that happen down there? Clearly overwriting memory, because it's all about shared memory. So you're overwriting some other application's memory, or you're corrupting memory. How does that work? Like, how are you able to catch that type of stuff?
Okay. In particular, the main line PreFAST and PFD therefore follows that, does a lot of checking for buffer overrun, in the sense that if you pass a parameter which is a buffer, you should pass size information as well. And PreFAST in general checks that the buffer you pass and the size information you pass are paired up and that they do make sense.
Okay.
And that is one of the major ways it protects from memory overruns. It's not perfect. It can't find every one of those. No static tool can find everything. But it does find a lot of the bugs that fall into the buffer overrun category. On the other hand, if you want to try to outsmart it, you certainly can. So don't. When it says do something, do the right way. Don't try to outsmart it, because ultimately you're just forcing a bug into your code.
Sure. Interesting. So last time we talked, we were in driver world, we talked to the framework people that have built the kernel driver framework.
Right.
And so are you integrated with them at all?
Yeah. The concept of annotations, and I'll get to answer your question in a second.
Good.
Is a generally applicable concept where you can say, for this API, here's some additional rules, here's some additional expression of the contract between the caller and the callee. And for KMDF, we have added a bunch of additional annotations to express the KMDF contracts. Currently, what PFD covers is most of the WDM interfaces and the KMDF interfaces. Additional annotations are clearly needed for other classes of interfaces, and we're working on that.
Cool. Well, let's talk about let's dig into the definition of the annotation. What exactly is this construct?
Okay, an annotation is a bit of source code represented as a macro, and for lots of reasons we really only want to talk about the macro expression of it. When you're compiling the code to actually build your executable, the macros are all translated away to just nothing. They just disappear, and your same old code is there. However, when you run it through PreFAST, the macros actually take on a value, and the macros say, in the very simplest case, double underbar in is one of those macros. It says this parameter is an input value, which further implies that it should be initialized, and that's something that PFD can check for. Did this value actually, this parameter actually get a value? If it has no value and you said in, it's going to give you a warning. For pointer parameters, in means that it better not be null. If you want to allow a null, then the annotation in opt, all one word, underbar, underbar, in, underbar, opt, says it's an optional parameter, could potentially be null. So the common annotations are in and out, and in opt, and out opt occasionally, and then the whole family of buffer annotations where you say this is an in parameter and its size is this other parameter name. And the syntax of that at this point in verbal form starts getting so muddy that
Sure.
it's better to look at the documentation.
Definitely. Excellent. So, since you've written this tool, you probably have a very good understanding of what's the most typical class of bug you're seeing driver developers write? Is there a certain...
It's tough because I've used it so much on our internal drivers, and the internal drivers have been pretty heavily beaten into submission in terms of being mostly correct. And on the internal drivers, when it finds a bug, it's finding something that's usually pretty obscure.
Okay.
For external drivers, we've had a few people who have been able to bring their code to the various labs that we've run for external drivers. And there we're finding a fair number of errors where you say, gee, I didn't know that particular rule. Things about use of the interlocked functions, and for this interview I don't want to go into the depth of that.
Sure.
But there are several ways that interlocked functions are commonly misused, because I think the documentation does a pretty good job of explaining them, but it's one of those things where you actually have to sit down with somebody who understands them for a few minutes and say, well, this is what it really means, and did you get it? And PFD provides a tool that at least says, no, you didn't get it.
Okay.
It's, at least you know it's wrong, and then you can know to go ask, as opposed to having it compile clean and then go off and do the wrong thing on you.
Sure. Well, that's excellent. That's why these tools are extraordinarily helpful. But it does beg the question: why does it have to be so extraordinarily complicated? Why are there virtually, without before the advent of say KMDF, such little abstraction, such little? Why do developers have to do the same things over and over and over again?
You're asking me a very hard question.
Sure.
I am not really a driver writer. I will freely admit that. Bluntly, from the point of view of actually writing a driver, I couldn't write a driver to get myself out of a paper bag. I'm more of a compiler person living in the driver's world.
Okay.
And I understand drivers. I've written drivers for other operating systems in the past, but it's very, very deep, dark past.
Okay.
And I really can't answer the question in a simple form, but maybe I can address some of it in an analogy.
Great.
We're still learning. Just as when computers first came on, it was very, very hard to write even the simplest application. And then for a period of a decade and a half, writing a compiler was worth a PhD. And today, writing a compiler is late undergraduate, or at least writing part of a compiler is late undergraduate education. In the same vein, we're learning how to express the semantics of what a driver is over time, but we do know that real-time applications, which ultimately that's what a driver is, it has to deal with events where the timing is critical, are hard to write, hard to express, and in a complicated operating system like Windows, you have to deal with expressing all of that concurrency and the mechanics of plug and play. And we're learning how to express that in better ways, and that's what KMDF is all about. KMDF serves the purpose of abstracting that knowledge, bringing it up to another layer. So just like in the compiler case, you're no longer writing a compiler in a low-level language. You now have all the tools that make it possible for an undergraduate to write a compiler. In the same sense, we're moving in that same direction. Now, if 2/3 of the developer community was writing drivers out there, it probably would have progressed a lot more rapidly. But there's a relatively small number of driver writers out there, so it hasn't progressed as rapidly as we might wish for, as important as it is anyway, because it is important to get the drivers right. It hasn't progressed as rapidly as it might have if there was a lot bigger audience out there.
Sure. But clearly, as you mentioned, it is, we are building frameworks that are making it easier for developers, and your tools like yours certainly make it easier for developers to find potential bugs.
Yeah.
So let's talk a little bit about you. I mean, what's your story? How long have you been at Microsoft? What's your background? You mentioned compiler development.
Okay. I have a fairly old PhD myself in formal language theory. I surprised myself by doing that. I'm not really that much of a mathematician, but that's where I ended up doing my PhD, is in formal language theory. And I spent almost 20 years at HP working both on some of their embedded stuff and on Unix software, oscillating back and forth between working on operating systems and working on compilers, and often, and that's when I was having the most fun, working on both at the same time. When you're working on a new port of an operating system, as I did both for Unix and for a very, very old version of NT, you often have to deal with the fact that new processor, compilers generating bad code. So one minute you're looking at the operating system and you trip over a bad instruction sequence, and you have to flip over, look at the compiler, figure out what the compiler is doing wrong, and either find a workaround in the compiler or get the compiler fixed, or fix the compiler yourself, which is all different variations on what I did.
Sure.
So to me, that's one of the most fun things to do, is that move back and forth between several domains. And that's why I find working on PFD a lot of fun. Is part of the time I'm thinking about drivers, even if I can't write one, and part of the time I'm thinking about compiler level technology. And it's an interesting back and forth.
Absolutely. So it seems like it's exactly what it is. It's a bridge between the compiler and the driver code.
Certainly one of many, but yes.
Sure. Very interesting. So speaking of which, I mean, you use the term concurrency, and that's obviously all the rage today as we enter the age of parallelism with the multi-core processors coming out. Do you foresee a time perhaps where driver developers could spend less time worrying about correct blocking semantics? And
yes, I envision such a time. I don't know what that world looks like, but I envision that world had better darn well come to exist someday, because we have to continue to move driver technology up and away from the dirty details, just as we have with the other technologies, so we can actually think about what our objectives are rather than fighting the details. Because ultimately the details drag us down in terms of what we can produce as something that customers actually want. We want to produce what customers want, not, a customer doesn't know what a driver is. They don't care. They just want their new widget to work right.
Exactly, and that's the way it should be.
And in fact, they want their new widget to work better than they expected. And in driver land, on average, we're doing, it works about as well as I could have hoped. And we need to get the technology to the point where we can say, we're delivering a product that is much better than what our customers actually expected. They plug it in, and they're just blown away.
Absolutely. Now, I know for, certainly a great amount of work has been done in Vista, the latest incarnation of Windows that'll be shipping in the not-too-distant future. With respect to drivers, a lot of the drivers have been moved into user mode.
Correct.
And there's also a user mode developer framework, or driver framework. We're going to also cover that on Channel 9. And so by moving them into user mode, they've done some very interesting work architecturally to limit the performance issues that may have, because there's going to have to be some sort of abstraction to get the information back into the kernel. And I know they've done great work to deal with that. So theoretically, it could be someday where there's no drivers, external drivers running in the kernel.
It certainly is. I won't say it's something wholly to be wished for, because of the fact that occasionally there's some new idea that somebody develops, and not all of the world's greatest ideas come from Microsoft. So the ability to write a kernel driver is probably always needs to be there, but it should be easy to write a kernel driver that you can focus on whatever your new widget might be. I don't have any great ideas for sample widgets, but use your imagination. And there will be some new widget that really needs a kernel driver. However, for 90-odd% probably of the new widgets, you don't need a kernel driver. User mode driver is fine. PFD works on user mode drivers. It doesn't yet have the annotations that KMDF does. Well, again, we're working on that, and I know who to beat up to get them to do that, but it hasn't happened yet. There's only so much time in any given release, and
absolutely. Well, I mean, and of course that begs the question that, is this technology open to be extended? I mean, if I'm a driver developer, and I'm building a driver for this device that my company's making, I certainly have an excellent idea of potential annotations.
Within the vocabulary of annotations that are provided, you can apply those annotations, and in fact should apply those annotations to your own functions. The vocabulary of annotations is going to grow over time, and as they do, you should continue to apply the new ones to your existing functions. But certainly, any new code you're writing, and to the extent that resources permit, old code, you should go back and apply annotations. Certainly the obvious in, out, buffer count, annotations that are there and documented today, ideally should be on every function in Windows. They aren't, and by in Windows I mean customer code, third-party code as well. They aren't. Major mea culpa here, because we simply haven't had time to do all that. That's a lot of work that would need to be done. But in the ideal world, if I could wave a magic wand and say poof, everything would be annotated, and I would take as a consequence of that once we started running PreFAST or PFD as appropriate, we'd find hundreds of more bugs.
Okay, interesting. So do you want to get into the details of how your tool works?
No.
Okay.
The reason for that is that to begin to talk about it, how it works, is itself at least a couple of hours.
Okay.
It's a fairly complicated technology, not because it's so horribly deep, but there's so much going on. And when I first had to learn about it, it took me several months to figure out exactly what was going on under the table, because I was just, okay, here's the code, go for it.
Yeah.
And we can't do it in the kind of time that we'd have available.
Sounds good. Cool. All right. Well, I mean, what's coming up? How do developers ask you questions? Where do they go? What do they do?
Okay, there's a mailing list, and I don't remember what the mailing list's name is.
That's fine. We can find that post facto.
And I respond to that mailing list. So far, the volume on that list has been small. There have been some PreFAST questions on the more general drivers mailing lists, and I have plenty of spies, if you will, on the other lists who forward anything that's relevant to PreFAST to me, and I respond either directly or through them to those. I'm more than happy to hear from at least a few customers. Thousands would be too many, but more than happy to hear from them with questions, issues, within the limits of various IP issues, any suggestions that you might have, because we want to make the tool better. We want to find new ways that drivers can be miswritten, catch them, report them, and make sure that nobody makes the same mistake twice.
Absolutely. Now, as I alluded to earlier, with tools such as what you've been working on, it seems that I don't know if shared source would be an interesting possibility, but since the driver writers, Microsoft isn't the only place that understands what could be right or wrong with kind of the patterns in driving. Clearly, but it is our operating system. We kind of understand what it needs.
Yeah,
so I get that.
Yeah.
But there's some really super talented developers out there that don't work for Microsoft that could also, such as yourself, add to. It could be more of a community effort. So it's always, and it seems like that's what's happening to some degree with the kernel mode driver framework. There's a community around that to some degree. So is that kind of thinking happening down in these depths of the world?
Not really at this point. We're certainly taking a lot of input, but in terms of sharing the technology, right now there's no plans for that, at least that I know of.
Excellent. Well, thank you for your time.
All right.
It's been great to meet you. This is very interesting technology. And of course, there'll probably be comments on Channel 9, so you can become a Niner. We need more, PhDs on Channel 9. But anyway, great to meet you. Thanks for your time.
You're welcome.
Take care.